Okay, today we will start with another distribution, probability distribution, very important distribution in statistics, in a statistical measure, the Poisson distribution. Actually, after binomial distribution, we will study now Poisson distribution. Actually, Poisson distribution was discovered by the French mathematician and physicist Simon Denis Poisson, 1781 to 1840, his lifetime, who published it in 1837. Actually, Poisson distribution is a limiting case of binomial distribution under the following conditions. That means these three conditions are applied for Poisson distribution. For n, the number of trials indefinitely large, sorry, and number of trials is indefinitely very large. That means the number of n number will be very large and tends to infinity. Now p equals to what? Actually, probability of success. The constant probability of success for each trial is indefinitely small. That means p tends to 0. And in the third, and p equals to lambda is finite. If we multiply with the number of trials and with probability of success, then this will be a constant lambda and is finite. This constant will be must be finite, where probability of success can be written as lambda by n, and probability of failure can be written as 1 minus p. That means 1 minus lambda by n. So we can find, we can derive the Poisson distribution as the limiting case of binomial distribution. That means from binomial distribution, we can derive Poisson distribution. Now, the Poisson distribution is a particular limiting form of binomial distribution where p or q is very small and n is very large enough. We have seen from the definition. So Poisson distribution can be written as probability of x, this or r can be written as probability of r equals to m to the power r e to the power minus m e to the power minus m divided by factorial r. Actually, this is the probability density function for Poisson distribution, where m is the mean of distribution. M is the what? Actually, mean. We have derived from binomial distribution, mean, variance, etc., third moment, fourth moment, etc. We have derived from binomial distribution in previous class. You can follow the binomial distribution from the lecture. In connection, we are studying Poisson distribution in connection with what? Binomial distribution. Remember it. First of all, you have to understand binomial distribution. So this is the probability density function for Poisson, m to the power r e to the power minus m and r factorial. Okay, where m is the mean of the distribution. M is the mean of the distribution. Now we'll try to prove this from binomial distribution in case of limiting case. Okay, now probability of r in binomial case, NCR q to the power n minus r p to the power r, right? From binomial distribution, NCR q to the power r n minus r p to the power r, where q is the probability of failure and p is the probability of success. So NCR can be written as q can be substituted by n minus p, 1 minus p, right? Because p plus q equals to 1, total probability equals to 1. This way we can write q equals to 1 minus p to the power n minus r into p to the power r. This equals to NCR. 1 minus p equals to p can be written as m equals to what? This is the mean. Mean equals to what? NP, right? And p equals to m divided by n. P equals to what? From here, m divided by n. Now putting p equals to m by n, where m is a constant, because mean is a constant. Mean can never be changed. This is why just putting 1 minus m by n. This is the actually series m to the power n r factorial, m to the power n, m by n to the power r, 1 minus m by n to the power n minus r. This is the NCR formula, combination formula, n into n minus 1, n minus 2 dot n minus r plus 1. That means n minus r minus 1, r plus 1. So this is the in denominator we are writing r factorial, NCR formula. Now dividing each each term of multiplication of factors by n. We can write n by n, n by n minus 1 by n, that means n by n divided by minus 2 by n in this way. Okay, just distributing this n to the power r. Actually, how many terms in this factor? Actually, r terms. This is why distributing r number of n, distributing r number of n in each value of each term of this factor. Now we get this divided by n, this divided by how many n here? Actually, r number of r n. Now m to the power r, this n to the power r used in this total n. So n minus 1 by n to the power n. 1 minus m to the power minus r become plus r in this denominator. Okay. Now this is the r factorial. Now n by n what? 1 minus 1 by n, 1 minus n by 2. In this way we get m to the power r, 1 minus m to the power r factorial, 1 minus m to the power r. Now taking limits when n tends to infinity, because a Poisson distribution exists a condition, n will be must be very large. Okay, n will be must be very large. So for a limiting case, n tends to infinity, this 1 minus m by n to the power n can be written as minus n by m to the power minus m, right? Minus m can be cancelled, so we back to the our first term. So this is the actually limit, standard limit, and this can be written as e to the power minus m. This is the standard limit of exponentiation e to the power minus m definition. And limit n tends to infinity, 1 minus m by r to the power r can be written as 1, because this standard limit result will be 1. Now putting this limits value in this term, then we get p to the power r, p of r equals to m to the power r. This will be what? This will be e to the power minus m, and this is the what? R factorial, right? R, only r factorial. This is the become 1. But what happens to this term actually? For n large, n tends to infinity, that means 1 by infinity what? 0. 2 by infinity what? 0. This something by infinity what? 0. 1 minus 0, 1 minus 0, 1 minus 0, that means what? These whole factors value what will be? Only 1. This why these whole factors becomes 1, and there is m to the power r, m to the power r, and this becomes this is the result of from limit values e to the power minus m, and this is the value what? Only 1, and this is the r factorial. So this is the required, our desired result of Poisson distribution density function. Density function of what? Poisson distribution. Understand everybody?
Yes, sir.
Now mean of Poisson distribution. Actually probability density function of Poisson distribution, p of r e to the power minus m, m to the power r divided by r factorial. This is the whole density function of what? Poisson distribution. Now we consider successor r. This is the random number. Successor r will be start from what? 0 to r. 0, 1, 2, 3 dot dot r. If we put r equals to 0 here, r equals to 0, then e to the power minus m, m to the power 0, 0 factorial. 0 factorial means what? 0 factorial what? 1. Remember it. 0 factorial means what? 1. I have a group, a mathematics for learning, but 0 factorial proved given here, given there. In this group, I have a post 0 factorial proof. You can visit the group. 0, if r equals to 0, then putting r equals to 0 here, we get this one. Just multiplication, rf, what, fr, what will be? 0. Now 1, putting r equals to 1 here, we get e to the minus m, m divided 1 factorial. Then multiplying, we get this result. Similarly, r equals to 2 will give this result, and multiplication will be this. And r equals to 3, multiplication will be this. For r equals to r, this. Just whole density function. So multiplying with this, we get this one. R into r factorial makes what? R minus 1 factorial, because r factorial can be written as r into r minus 1 factorial, right? R cancelled in this multiplication. Now summation of r can be written as 0 plus this, third plus, fourth plus dot dot r term. So we can just adding. Now taking e to the power minus m into m will be common from from every term. Okay, taking e to the power m into e to the power minus m term from every term, we get this one. Actually, this is the series of what? Exponential form. 1 plus x by factorial 1 x square by factorial 2 plus dot dot x to the x to the power n by factorial n. Okay, plus dot dot infinity. That means this is the series of what? Exponential function e to the power m, right? Exponential form. So e to the power m, this can be written as, so e to the power minus m, e to the power m will be what? Cancelled. This is the only m. So summation fr will be what? Only m. But now we must know mean equals to what? Summation fr divided by summation f. Summation frequency, total frequency what? Total frequency will be 1. Total frequency what will be? 1. Therefore m by 1. So mean equals to what will be? Only m. Now standard deviation with similar process from binomial distribution. Just successor r will be 0 to 1 2 3 dot dot up to r, and frequency will be, if r equals to 0, this value multiplication product rf uh, will be 0, and product r square f, that means making square this, then multiplication. Okay, 0 square into this will be 0. Now putting r equals to 1, we get this from probability density function of Poisson distribution. Then square this, multiply this will be this. So if r equals to 2, then this multiplication will be this. 2 factorial and 2 cut, cancel. So square, taking square, multiply with this, then we get this one. In this way, after multiplication up to r successor, then we get this, the whole formula of probability density function of Poisson distribution. Now just multiplication the r into this, then this r factorial becomes what? R minus 1 factorial, because r factorial can be written as r into r minus 1 factorial, and r will be cancelled. Now making square this with this multiplication, now we get this one only. From look like above, summation of all frequency what will be? 1. Summation fr equals to what? M. We are derived here. Summation fr equals to m. So summation fr square what will be? Just making sum of all term, 0 plus second term plus third term plus fourth term plus dot dot up to r plus 1 term. So we get this whole series, infinite series. This is actually. So taking common m into e to the power minus m will be common. So this is all another infinite series. Actually, this infinite series can be written as like this. How? This twice m making single. This m square by 2 making single, m square by factorial 2. 4m square, only m square, m cube. This also making single. So we can make another series with what? There is only used only single m. Another m will be this. Okay. So only single m square by 2 factorial 2 here. So another 2 m square by factorial 2 will be here. So here you have used only m cube by factorial 3. So another 3 m cube by factorial 3 are here. Dot 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 dot. One single m to the power r minus 1 divided by r minus 1 factorial are used here in first series. In the rest series, r minus 1 factorial, r minus 1 term. Okay, plus dot dot. This is infinite series also, and this is also in an infinite series. So we can make second bracket with we can close with second bracket the first series, and taking common m from every term of the second series, we get m into second bracket. This is the second series. So this is another series of what? E to the power x. Okay, 1 plus x square by factorial 2 x cube by factorial 3 in this way. This is the infinite series of e to the power x. That means e to the power m will be the result here, first series. And second series will be another series of what? E to the power m, right? So m into e to the power m. So combinedly we can write m plus m square. So variance sigma square equals to summation fr square divided by summation f minus summation fr divided by summation f whole square. Actually, these four result known from what? From mean and from this table. Okay. Now sigma square equals to can be written as, this is the result of what? M plus m square. This summation f1 and summation fr by summation f. What will be? M. Right. This is the mean actually. Right. This is the mean. Summation fr divided by summation f equal to what? Only m, single m. This is why m square. Now just m square cut, only single m. So sigma square equal to m. Sigma can be written as square root over m. This is the standard deviation actually. If you take the square root of variance, then you get standard deviation. Standard deviation is a square root over m. Hence, the mean and variance of a Poisson distribution are equal to m. So we observe that from above two result, we have found a mean and we have found also variance, but this is identical, right? M. Similarly, you can obtain mu3 equals to m and mu4 equals to what? 3m square plus m. Similarly, kurtosis can be calculated with a similar process of binomial distribution. Beta 1 can be written as 1 by m. Beta 2 equals to what will be 3 plus 1 by m. Similarly, gamma coefficient also called Pearson's gamma coefficient, can gamma 1 will be 1 by root m, gamma 2 will be 1 by m. This is left for you. You have to calculate this result. Look like binomial distribution. We have derived this whole in binomial distribution. Similar process you can find this in Poisson distribution. Now mean deviation. Okay, actually mean deviation show that in a Poisson distribution with unit mean, and the mean deviation about the mean is 2 by I times the standard deviation. We have to show this hypothesis, this result, so that in a Poisson distribution with unit mean will be what? Unit, and the mean deviation about the mean is what will be? Twice divided by I times the standard deviation. Now we know probability density function of Poisson distribution is this, but mean will be what? Unit. Unit means what? 1. That is m equals to what will be? 1. Standard deviation what will be? Square root m equals to what will be? 1. Hence, probability density function of Poisson distribution can be written as e to the power minus m divided by r factorial. M to the power r means what? 1 to the power r. Okay, 1 by e into 1 by r factorial. Okay, hence we can arrange a table using this probability density function. This is the actually successor in first column 0 to r, like before. Probability density function will be this derived probability density function. Okay, putting r equals to 0 here, we get 1 by e only. 0 factorial means 1. 1 by 0 factorial means only 1. Now the mean deviation about mean r minus 1, absolute value r minus 1, and this will be the r minus 1. This is the actually deviation rate of deviation. So multiplying probability density function with this, we get the fourth column. Now if r equals to 1, then we get this, and just if we take difference, if we take difference, then we get this. Then if we if that equals to 2 factorial, what will be? 1 by e, 1 by 2 factorial, then r minus 1. R minus 1 will be what? 1. 1, 2, 3 dot dot r minus 1. Actually, this is the deviation number starting from 0 up in above will be positive, and in below will be also difference will be positive because there is absolute value. Now if we take sum of this fourth column, summation probability of r minus 1 absolute value, then we get 1 by e 0, this term up to infinity. Then if we take a 1 by e from every term, 1 by e every term, we get series. This whole series can be written as 1 plus 1 by factorial 2 can be written as 1 by 1 factorial minus 1 by 1 factorial. Okay, 2 by 3 factorial can be written as 2 by 2 factorial minus 1 by 2 factorial, and 3 by 4 factorial can be written as 3 by 3 factorial minus 1 by 3 factorial. So 4 by 5 4 by 4 factorial can be written as 4 by 4 factorial minus 1 by 4 factorial. Then you can write the up to r minus 1, r plus 1 term, this up to infinity. So this whole series, there are two 1, 1 by 1 factorial, 2 by 2 factorial, 3 by 3 factorial. In this first term, taking first one, we get the first series, and taking the second one, we get the second series. So there are actually 1 plus, this is the first series, and minus, this is the taking common from every term, we get all are positive second term. And if we put 1 in this second series, this one we have to plus 1, we have to take another plus 1 to balance the series. Now this is the series of what? E, exponential series. Okay, this is the series of e to the power 1, x equals to 1, this is why e, and this is the also series of e. Now we get twice divided by e into 1, that means 2 divided by e into a standard deviation. 1 equals to what? Standard deviation. Proved. This is the actually a theorem we have proved. If the variance of a Poisson distribution is 2, variance of a Poisson distribution is 2, find the probabilities for r equals to 1, 2, 3, 4. That means there are 4 successors. From the recurrence relation of the Poisson distribution, also find probability of r greater or equal to 4. Variance m equals to what? 2. Mean equals to what will be? 2. This is also given. Now probability of r plus 1 equals to m divided by r plus 1, probability of recurrence relation. Actually recurrence relation, in this recurrence relation, this is the recurrence relation. Okay, using this recurrence relation, just putting now m equals to probability of r plus 1 divided by m equals to what? 2. This is why 2 divided by r plus 1, probability of r. Now r equals to 0, probability of 1 what will be? Just putting r equals to 1, 0, then we get this result. Understand? Probability of 0 equals to what? Probability 0 e to the power minus m e to the power minus 2 square. Just using scientific calculator, we get the value of probability of 0. Similarly, if r equals to 1, then you get probability of 1. Probability of 1 will be what will be? Probability of 1 e to the power what will be? E to the power minus e to the power m equals to minus 2. Similarly, r equals to 2 and r equals to 3, we get probability of r greater equal to 4. Greater equal to 4. This is why probability of 4, 5, 6, dot dot etc. up to infinity. Now, if we want to find out the whole sum, if we subtract 1 minus just this 3, if we total probability is 1, we must know total probability is 1. So if we subtract just these 3, we get the whole infinity, right? Just subtracting this, we get the result. Another example 2. Where is the example? Assume that the probability of an individual coal miner being killed in a mine accident during a year is 1 divided by 2400. Use appropriate statistical distribution to calculate the probability that in a mine employs 200 miners, there will be at least an fatal accident in a year. Okay, you have to use a statistical distribution to calculate the probability that a mine employee 200 miners, there will be at least a one total accident in a year. So probability is given 1 by 22400, and total number of what? N equals to 200, total number of miners. So we must know m equals to mean equals to np, right? M equals to m equals to can be written as this equals to 200 by 24, 1 by 12, right? N by p. So just multiplication, taking this multiplication, we get only 1 by 2. Now at least 200 miners, right? 200 miners. So probability of at least 200, at least 1, probability of 1 or 2 or 3 or dot dot up to 200. What will be? In statistical, in probability calculation, in replace of r, we have to use plus sign. That means this can be written as probability of 1 plus probability of 2 plus probability of 3. This is union. This is why up to probability of 200. This equals to total probability minus probability of 0, right? Minus probability of 0. 1 minus probability of 0. We have to put r equals to 0 in the probability density function of Poisson distribution. You know, probability density function of Poisson distribution e to the power minus m to the power r divided by r factorial. Just putting r equals to 0 here. Okay, probability of 0. Now if you subtract this probability from 1, we get this e to the power minus 1 by 12. You have to find out this value using the calculators. Then we get 0.92 will be, this is the 0.08 is the result. Example 3. Suppose 3% of bolt made by a machine are defective. 3% bolt are defective, and the defects occurring at random during the production. If bolts are packaged 50 per box, find number 1 exact probability, and number B Poisson approximation to it, and that given box will contain 5 defectives. That means we have to find out the two conditions. First of all, 3% are defective. Therefore, probability P equals to 3 by 100, 0.003, 0.03 only. Now from A, we are finding a probability of Q. What will be total probability 1 minus probability of success P. This is why 0.97 are the Q. That means not defective. So hence the probability for 5 defective bolts in a lot of 50 per box. Okay, 50 NCR. NCR means what? 50 C5. Okay, successor 5. So 50 C5 P to the power 5 and Q to the power 50 minus 5. That means 45. Then using binomial distribution. Using binomial distribution, we get this result. Now, secondly, exact probability, it is calculated from binomial distribution. Now, Poisson approximate. Now, to get Poisson approximately, m equals to what will be np, right? M equals to np. So n is 50 and p is the 3%. This is 3 by 100. This is the calculated by 3 by 2, only 1.5. So recurrent Poisson distribution approximately m to the power r e to the power minus m divided by factorial r. Just using the values and putting the probability density function of Poisson distribution, we get this result. Actually, previous result 0.013074, but in Poisson 0.01412. If we compare the result. Okay, today is the end of this class. I hope everybody will practice, and next day the rest of the part will be studied. Till then, thank you.